Hello everybody and welcome back. We're looking at question number 18 now on the 9th grade level multiple choice contest, the 2004 Pascal paper. Okay, so the symbol A, B, C, D written in the sort of four box, bigger box sort of thing equals AD minus BC. Okay, if we've got x minus 1, minus 5, 3, 2, all that equals 9, the value of x is, okay. So with this question, they're not doing anything particularly fancy. They're just introducing brand new notation right off the fly. They do this every once in a while. In the past, I've seen things like let A triangle B be something like A times A minus B. And they just give you a brand new thing to do, and now it's just up to us to, can we apply this brand new definition that we've never seen before to this new situation and get the value of x? There's not going to be a whole lot of trickery here. One thing I would like to say, however, this arrangement A, B, C, D as a square equaling this value, if you're doing a grade 9 contest, odds are you're not going to know this stuff, but so we have A, B, C, D. This is very similar to what are called matrices, which are rectangular arrangements of numbers. And if you take a 2 by 2 matrix, 2 rows, 2 columns, you can actually do what's called the determinant. Again, you're probably not going to know this, and you're certainly not going to need to know this or see this until something like grade 12, or more likely like a linear algebra or matrix algebra course in university. I just thought I'd say, hey, this is kind of nifty. If you take a 2 by 2 matrix, you can actually calculate its determinant using the expression A times D minus B times C. So really what they've done is they've taken the arrangement of these four numbers, and the calculation that we're doing is the determinant of that matrix. And you can sort of tuck that away. I'd encourage you to maybe, if you want to, try and look up matrices. There's some interesting stuff there, very interesting math. And it's a relatively simple concept, just arranging numbers in a particular way and treating a group of numbers as a whole object rather than individuals. But if you do look it up and you say, no, that's not for me, or whoa, what the heck's going on, that's way too complicated, don't worry, you're not going to see it until very late in high school, very early in university at the most. Okay? But it is some interesting stuff, and I just thought I'd like to mention it because I made the connection there. It doesn't particularly help us answer the question, but what have we got? We are told, I know we've got x minus 1. I think we had minus 5 down here. And let's just x minus 1, minus 5, 2, and 3. So we're told this, and we know that the box, the squarey expression, turns into A times D, so x minus 1 times minus 5 minus 2 times 3. So all we've done is we've changed the symbols on the left hand, or the symbol on the left-hand side, into an actual expression. This expression AD minus BC here. Okay? 2 by 2 matrix determinant. Alright, and now we can start simplifying. So x minus negative, so we're going to get negative 5x, and then minus 1 times minus 5, that's going to be plus 5. Minus 2 times 3, so that's minus 6, equals 9. These can be replaced with minus 1. So negative 5x minus 1, negative 5x, bring the 1 over to the other side, 9 plus 1, 10, and divide by 2 on both, or negative 5 on both sides, and you'll get negative 2 as our answer. Okay, so negative 2, and is that one of the possibilities? Yeah, it's right there in the middle. It's C. Okay. So, good little question, and maybe, just maybe, I've started some of you out there on the path to understanding matrices just a little bit earlier than you normally would. But either way, we can forget all of that and move on to question number 19, which I'll do in the next video.